just to save time, I'm not going to write down the definition of capacitance. Just think about the formula. What's the formula for capacitance if you looked it up? Do you remember? Charge over voltage. So from that formula you could get capacitance is a measurement
of charge.
Yeah, well, let me phrase the English carefully here. Capacitance is how much charge can be held in a capacitor per unit voltage across the capacitor. Something like this. Yeah. Now look, you can look this definition up in your notes, but as you can see, I don't have these definitions memorized. So I just need to think about the formula. The formula is Q over V, and capacitance is for a capacitor. So you can say capacitance is a measurement of how much charge can be held in a capacitor when there is a potential difference, or per volt potential difference across the capacitor. And what's the unit? Well, the unit is coulomb per volt, but there's another name for coulomb per volt. Yes, what is it? Farad. Is that right? Okay, so I'm not going to write that down. You can look that up in your notes. Okay. What I really care about right now is the number crunching. So you have an 8.5 connected to a 40. What's the charge and what's the energy? So you have an 8.5 microfarad connected to a 40 volt. What's the charge? So Q equals C over V. No. Q equals CV. So 8.5 times 10 to the minus 6 times 40, and you get 3.4 times 10 to the minus 4 coulombs, or if you want to put that in millicoulombs, that is 0.34 millicoulombs. And then the second part is what is the energy stored. That's a half CV squared. That's a half CV squared, and you get 6.8 millijoules. Did you get that? Yep. Okay, so the next part, you have this circuit 486210. 4, 8, 6, 2, and 10 volts. And these are all in microfarads. What is the energy stored on the capacitors? So first we have to add up the total capacitance. So when I add these two together, I get 10. So I have to add a 4, a 10, and a 6. So that will be 1 over 4 plus 1 over 10 plus 1 over 6. I'll double check, don't take it personally. 1 over 10 plus 1 over 6. Flip that upside down, and you can get the final answer. Capacitance equals 1.94 microfarads. So we would like the work, which is a half CV squared so let me double check that, it's quite small.
14.4 microjoules.
It's pretty small, let me just double check that. So that's the C, it's a half of that times the voltage, which is 10 squared. Yeah, it's tiny. It's 97 microjoules, if you want to write it like that.
It's 40 V.
The
V is 40, not 10.
10.
Yeah, 45. Oh yeah, 45.
Yeah. We cool? So far. Oh yeah. Yeah. Actually, you know what? Just to make a point, let me write in the definition. So, capacitance measures how much charge per unit volt a capacitor. Capacitor? I don't know how to spell capacitor right now. How much a cap, that will do, per unit volt a capacitor can hold. Ah no, I should spell this. That's it?
Yeah.
It looks wrong.
It's right.
No, right. Okay, now let's look at the D part. You don't need to write that down because I said it's better if you look up the definition. Oh, and the unit is coulomb per volt, which is also called a farad. Okay. D. A 50 micro is charged at 350. Okay, so what you have here is a 50 micro, and then the charge is 350 microcoulombs, and after 2 minutes it falls to 250. So then after 2 minutes the charge is 250 microcoulombs after 120 seconds. What is the resistance here? So what's happening is this here is connected to a resistor. Let me draw that better. Resistor. Right, so after 2 minutes, 120 seconds. So your formula, let me think, it's the RC one now. Do I have the C? I do, but I don't have the T. So what I need to do, rats, I'm going to need to use this formula. Q equals Q0 E minus T over tau. So you'll have 250 micro equals 350 micro E minus 120 over tau. Now can you solve this for tau? You can. How many unknowns are in this equation? Just the one, because those micros cancel. So let's do this. 250 divided by 350, log the answer, divided by minus 120, flip the answer. So after you go through the algebra, you get tau equals 356.6 seconds. Now that's not what you want. Like you said, Fahad, you need to use the formula tau equals RC. So R equals tau over C, which will be 356.6 over 50 micros. So this should be pretty big. Should be like in the megas. Yeah. It's 7.13 mega ohms. Part 2. What is the time taken for the charge to fall to 150? So now we have 150 micro equals 350 micro E minus T over tau. So again, this is just like what you did in maths in semester 1, isn't it? On the chapter of exponential and logs. So we have 150 divided by 350, log the answer, divided by multiplied by minus 356.6. And I get here T equals 312.2 seconds. T. And lastly, what is the voltage after 5 minutes? So the voltage after 5 minutes equals the voltage at the start. E minus 5 minutes is 300 seconds over 356.6. So it's V times 0.4312. So if we knew the voltage at the start, we could finish it. Did I give us the voltage at the start? No. So, but you can use this formula. Q equals CV. So V equals Q over C. So this is the charge at the start divided by the capacitance. So multiply 50 micro, and what's the capacitance? No, the capacitance is 50 micro rats. The charge was 350, wasn't it?
Yeah.
At the start.
Yeah.
And the capacitance is 50 micro. So I get here a voltage of 3.16 volts. So it took me exactly 10 minutes to do that section B question. The whole thing. Every single part of it, 10 minutes. And you had 30 minutes to do it. All the formulas were straightforward to use. There wasn't anything too complicated. The only maths in it was maths that you've seen from semester 1 with the exponential, using the logs to find the terms. I mean, really straightforward question. Straightforward electricity question. Should be nearly 20 out of 20 if you got this in the exam. You should be very happy. Okay, so I think what we'll do next time, we might do a bigger Kirchhoff question. Yeah, something like this. Anyways, what